line to either be super steep, not as steep, go upward, downward. That's what we call slope. So today we're only going to be looking at the number next to the x, because that's what causes the line to move. So if you notice, this is every time the y moves, the x moves. Every time the y moves, the x moves. So we are going to be looking at that today and why that happens. And what we call that in algebra is what we call slope. So first you have to understand slope. You've probably heard slope before with skiing. If you've been skiing, you go down the slopes. The steeper the slope, the harder the hill, right? If you've been on a roller coaster, the steeper the drop, the more scary, right? Little kid roller coasters aren't very steep. They literally just go like this, right? Where a big kid roller coaster is pretty steep. So we're going to look at the slope or the tilt or the steepness of a line. If a line slants upward, so if you notice on this one, you always read lines from left to right, just like a book. If it goes upward, like that, it has a positive slope. If it goes upward, it has a positive slope. So basically, that is like going up the chairlift at the ski slopes. When you're going up the stair, you're going up the hill. That's going upward. That's a positive slope. We don't say an upward slope. That doesn't make sense. You say positive slope. If it goes downhill, like here, that's a negative slope. If it's a vertical line, basically you're dropping straight down vertical, like this, that's undefined. There's really not a slope to that. We can't say there's slope, so we call it undefined slope. And then, if it just goes side to side, basically like a little kid roller coaster, this is what we call zero slope. There is no slope to it. It literally is just a straight line. Like a plane, a farm is basically zero slope. Typically a farm is a very just straight and has zero curvature to it. Alright, question. We are going to look at how you calculate slope. And slope is the rise over the run. So in other words, how much do you rise over how much do you run is what it's talking about. How much do you go up or down compared to how much you go side to side. So rise is your y's, run is your x's. Everybody with me? Because rise is on your y's, side to side, or your run is on your x's. Everybody with me so far? Rise, run, side to side. Okay, so we're actually going to cross out this bottom part, because I don't love it. We're going to cross it out. I did love it, I don't love it anymore. Alright, so always remember it's rise over run. Y is over x. Y is always going top, x is always going bottom. Everybody with me? Rise over run, y over x. And we use n to represent the slope. I don't really know why, but mathematically. Alright, there's three situations where you're going to be asked to find slope. Three situations where you're going to be asked to find slope. Slope is rate of change, which means it has to be the same constantly. So if you're in a table and all of a sudden it goes like up 20 and then down 10 or up, it has to be moving at the same. So how much are the x's moving in this table? Every single time the x's are moving at what? Plus 2. Plus 2. Every time it goes plus 2, plus 2, plus 2, plus 2. Does everybody see that? Everybody with me so far? I would be writing this down if I were you. Alright, and then your y's. How much are your y's moving? How much are your y's moving? How much are your y's? Raise your hand when you have an answer. How much are your y's moving? Sharman? 8. So plus 8, plus 8, plus 8, plus 8. Everybody with me? Everybody good so far? Alright, so we know slope is rise over run. We also know it's y's over x. Y's are always on top. Alright, so how much are my y's moving each time? Everybody? 8. So on top it's going to be in 8. How much are my x's moving each time? 2. So my slope is 8 over 2. But that can be reduced. What can 8 over 2 reduce to? Everybody? 4. 4 over 1 or just 4. But this is why we leave it as fractions. Because now we know every time my y's go up 4, my x's go up 1. So let's do this. If my x goes to 1, it went up 1, what is now my y? Every time my x's go up 1, my y's go up 4. So it's 3 plus 4? 7. So let's say I'm going from 8 to 9. What would my y's be then? Raise your hand, please. Appreciate that. If my 8 goes up to 9, what would my y's then be? Every time my x's go up 1, my y's go up 4. So what would it be? Joshua? 39. This is what slope allows us to figure out. We can figure out multiple points. So your slope here is 4 over 1, or you could just say 4. So would this line go upward or downward? Up, because it's what? Positive. When you have a positive slope, your line goes upward. Questions up to this next one. Let's say I'm given a graph. Let's say I'm given a graph. I like graphs the best. So graphs is the same concept. You have to pick points that fall on the line. You can't just be like, oh, I really like -4, 1, so I'm going to come over here and pick -4. You can't do that. They have to fall on the graph. Everybody with me? So I'm going to pick 2, 1, and 5, 0, 5. You can pick any 2 you want. It's still going to work. Those are just the 2 I'm picking. Everybody with me? All right. So first let's figure out, is this a negative or a positive slope just by looking at it? Is it a negative? Is it going upward or downward just by looking at it? Miller. Read it from left to right. Okay. Downward. So if you notice this is going down. Everyone see that? So is it a negative or a positive slope? Negative. So automatically I would put a negative so you don't forget. Because it's easy to forget that negative. But it's going downward. Alright, so it's rise over run. Or y's over x. Everybody with me? Alright, so I want to go from this red dot up to this red dot. Everybody with me? So if I'm here, how much did I rise to get 1, 2, 3, 4? How many did I rise? 4. To get to in line with this red dot, I went 1, 2, 3, 4. So I rose 4. Everybody with me? How much did I then run? How much did I have to go side to side? 1, 2. So my slope is -4 over 2. Can that reduce though?
Yes.
Yes, what can that reduce to?
2.
-2 over 1. Or just -2. Now, let's see if this works. We're saying every time I go up 2, I should go over 1. Let's try it. Let's go from this point to this point and see if it works. So I should be able to go up 2 over 1. Up 2 over 1. Did it work? Let's see if it works again. This one should take me to this point. Up 2 over 1. Did it work? Up 2 over 1. Up 2 over 1. Perfect. So the slope here is 2 over 1. Thank you. Questions? Yes. So I like to label x is y's and slope is rise over run. Everybody with me so far? So, and that's y's over x. So how much did my y's change from 7 to 10? 3. So 3 goes on top. Anyone confused at where I got 3? How much did it change from 4 to -2? Be very careful here. Did it go up or down, first of all? Down, so we know that's a negative. If it's going down, that's a negative. And it went from 4 to -2. Start on -6. So my slope is 3 over -6. Or what can this reduce to? Yep, negative x. Both of these are perfectly fine. Just based off those 2 points, I can still find the slope. Because it went from 7 to 10, which is 3, and then from 4 to negative 2, which is a change of 6. And it went down, which is why it's negative. Just start here. Where do I get the y? Because 3 divided by 3 is 1. 6 divided by 3 is 2. So,
Really long.